Stealth planes, known in Spanish as furtivos, are extremely important in current air forces. We have all heard of the Sukhoi 57 or the F-22 Raptor. While it is true that this type of technology is ultra secret by the involved countries, researching can scratch a lot of information. And that's what I've been doing for over a year. Welcome to a new series on this channel about stealth planes. To tell all this in detail, I have traveled to the United States to visit each and every one of the United States stealth planes. Why are there only 2 companies in the United States that can make this type of plane? Why did Northrop choose to make smooth surfaces unlike Lockheed Martin? Or why did the Air Force force Northrop to design the B-2? Is that what you're about to find out? During the Cold War, the Soviet Union made tremendous development in its air defenses. The United States discovered this from their own experience in the Vietnam War, when the North Vietnamese surprised the Americans thanks to the air defenses that the Soviet Union provided them. The Americans didn't quite know how they could evade these defense systems, so they started brainstorming and accepting all kinds of proposals. For this, in the United States, there is an agency known as Defense Advanced Research Projects Agency, which stands for Defense Advanced Research Projects Agency, with which they study ultra-futuristic technologies. Being aware that most will not proliferate, but these are such advanced projects that if one goes ahead, it can give a great advantage. In 1974, Defense Advanced Research Projects Agency released an ultra-secret competition among aeronautical companies to study 2 things. The first was the study of the shape and characteristics that an aircraft would have to reduce its radar signal, and the second was to study whether such an aircraft was viable to manufacture. The companies that Defense Advanced Research Projects Agency proposed to participate were Fairchild, Grumman, General Dynamics, McDonnell Douglas, and Northrop. The first 2 didn't even accept the proposal and ran away from that project. However, General Dynamics was skeptical about this approach to the problem. They believed it was much better to develop good electronic warfare measures, so they also abandoned the project. The last 2 companies did accept the challenge and received $100,000 to investigate it. Adjusted for inflation to 2024, it would be equivalent to receiving $630,000. This project was known as Project Harvey. Defense Advanced Research Projects Agency put out this contest as a result of having previously worked on a mini-drone project which showed that by changing its geometry, it could change its radar signal. So they wondered if this could be applied to a full-sized plane to use it as a fighter jet. Lockheed was not selected by Defense Advanced Research Projects Agency in the 70s because in the prior decade they developed many planes but no fighter jets. The last fighter they developed was the F-104, which first flew in the year 1954. That was already 20 years ago, and since then they had released other types of aircraft like the P-3 Orion, the C-141, or the S-3 Viking. They were great planes but not fighters, and they needed fighter manufacturers at that time. Meanwhile, Lockheed had developed the A-12. But this project had such an extreme level of confidentiality that Defense Advanced Research Projects Agency didn't know about the existence of such a plane. Had they known, Lockheed might have been included in the competition. Since the reason why the A-12 has that cobra-shaped neck was to reduce the radar signal. Before the A-12, Lockheed had already made major changes to the U-2 to decrease its radar signal. But Defense Advanced Research Projects Agency didn't know this either. That is, Lockheed already had some experience in hiding radar signals. In case you didn't know, the A-12, flown by the CIA, was the first Blackbeard plane. It's commonly known as the Strategic Reconnaissance 71, but that was the version used by the Air Force. Actually, the A-12 and the Strategic Reconnaissance 71 were practically identical. Ed Martin, Lockheed's Science and Technology Director, discovered Defense Advanced Research Projects Agency's newly announced competition. He spoke with Ben Rich, who at that time was the president of Scanworks at that time, and they wrote to Kelly Johnson, the former director of Lockheed, to pull some strings and also be invited to participate. What Johnson did was talk to the CIA to allow Lockheed to tell Defense Advanced Research Projects Agency about the A-12 project. Because at Lockheed, they knew that as soon as they showed Blackbeard to Defense Advanced Research Projects Agency, they would be welcome to participate in the contest. They finally succeeded, and when Defense Advanced Research Projects Agency saw the A-12, they indeed gave Lockheed the green light to enter the contest. The problem is that it was already too late. All the money had been distributed between McDonnell Douglas and Northrop, so there was no funding left for them. But Lockheed's response was emphatic. They were going all in. Would they put the money out of their own pocket? One of the biggest bets in aviation history, no doubt. In case the previous names don't ring a bell, they are true legends of the aerospace engineering world. Scanworks is the department within Lockheed where the most advanced topics are dealt with. Penrich was the president of Scanworks for many years. He later wrote the book Scanworks, one of my favorite books, and Kelly Johnson was the one who led the projects of the F-104, the U-2, and later the Blackbeard. With the U-2, Lockheed learned that you can't redesign a plane to make it undetectable. It would have to be designed from scratch with that goal in mind because modifications to an already manufactured plane were extremely costly and the result was not worth it. In 1960, Gary Powers was shot down while flying a U-2 on a spy mission over the Soviet Union. As a result of that event, the Blackbird project was started and it was required that the plane be slightly undetectable to radar, because they didn't want tensions with the Soviets for flying planes over their territory. This was practically at the United States President's request because the Soviets could not shoot down the plane. The simple fact that they knew they were being flown over would increase tensions with the United States. So they wanted them not to find out. That is, they were going to continue flying over the Soviet Union and spying on them, but they didn't want them to know. And that's how the A-12 was the first plane designed with the goal of being slightly undetectable to radar. It's only fair that, before we continue, we explain how a radar works. Generally, we will always have an emitter of electromagnetic signals and a receiver. When the emitter emits a wave, the receiver starts listening to see if it detects anything back. If it detects it, it will mean that there has been something in between that has bounced the wave back. And since electromagnetic waves move at the speed of light, it is possible to know how far away the object that bounced the wave back is. In addition, it is also possible to know how big the object is, depending on how intense the received reflection was. Knowing this simple theory, it is clear what a stealth aircraft has to do to prevent any electromagnetic wave that reflects off our aircraft from returning to the receiver. Lockheed and Northrop's initial proposals were very similar, but McDonnell Douglas's differed greatly. All three companies realized that a flat surface reflected all electromagnetic waves at the same angle of incidence, as if it were a mirror, and that signal was quite strong. If the surface is curved, the electromagnetic waves are reflected in all directions with less intensity. Lockheed and Northrop thought it was better for all electromagnetic signals to go in the same direction, and they would focus on sending that signal elsewhere so it wouldn't return to the receiver. Both designs were based on an aircraft formed by planes. McDonnell Douglas, on the other hand, designed aircraft with curved surfaces, so that the signal received by the receiver was very weak, so much so that the receiving antenna might confuse it with background noise. Defense Advanced Research Projects Agency had set a target value for the return radar signal for the initial designs, that is, the proposals had to be below that return value to be considerable. Invisible, Lockheed and Northrop achieved it, however McDonnell Douglas did not. But they claimed that by using electronic warfare measures, they could make their aircraft virtually invisible. But, as had previously happened to General Dynamics, this is not what Defense Advanced Research Projects Agency was looking for, so they were disqualified. Between Lockheed and Northrop, $1.5 million was divided. Adjusted for inflation, this would be equal to receiving $10 million in 2024. Now was the time to build a static model of the aircraft to test it on a pedestal. The prototype that returned the smallest radar signal would win, and 2 prototypes would be manufactured to finally fly. In the United States, since the beginning of the Cold War, they chose to translate all Soviet papers to study them later, just in case there was some amazing technology they were overlooking. In fact, it is said that given the amount of documents they had to translate, it was at this time that they began to consider the option of using computers to translate documents. But the computational power of that time was not enough, so it was not really until the 80s when this technology began to be used. Prior to all this, in the early 60s, a Soviet electrical engineer named Ufimtsev published several papers on wave refraction theory. This article was translated in 1971 by the United States Air Force. When they realized that this was the key to hiding an aircraft's radar signal, panic set in. Since the article had been published 9 years before being translated in the United States, what things could the Soviet Union have by then? Surprisingly, nothing. They overlooked its usefulness. A Northrop engineer stumbled upon these translated works and shared them with his colleagues. Lockheed discovered the existence of FinChef and its publication years later. By then, they already knew that flat plates bounced waves in a single direction, because they had been working with the A-12 and the U-2 to reduce radar signals. So both at Northrop and Lockheed, the key question at this point was how to orient all these plates on the aircraft so that the radar signal was minimal. A Lockheed engineer and mathematician known as David Oberholzer said he was capable of developing software that calculated the radar signal bounced off an aircraft. He also stated he required about 6 months. Lockheed informed him he had one, but they would provide all required resources. He had it a month later. They nicknamed him Echo. The program let you input flat surfaces and calculate their radar signal at different angles. For weeks, Lockheed left all the computers calculating. From night to the next morning, the results were analyzed, and in the afternoon, a new proposal was sought to launch that same night, iterating daily until the optimal result is achieved. Since this program was not capable of calculating with curved surfaces, its aircraft would only have flat surfaces. Finally, they came to the conclusion that the best proposal would be a shape similar to that of a diamond. But to make this geometry a flyable aircraft, they realized they would have to modify the tail part. Until June 1975, they had only trusted the software, but then everything changed. They made a piece, checked the radar signal with software, then implemented it, surprising everyone. The ECO program worked. The results were very similar to what had been simulated, which meant they could design an aircraft based on that software, because they had already verified that it worked. And that's how Lockheed developed their prototype. Northrop came to the same conclusion as Lockheed. They would use flat surfaces because they worked well and could be modeled. They also created software called GenScat. The key difference with Lockheed was their lack of complete trust in the software. At Northrop, engineers were highly valued, so their understanding of wave reflection was trusted. Just like Lockheed, who had been previously working to reduce the radar signal with other aircraft, Northrop was also doing it, so the engineers knew what they were talking about. In the third video of this series, we'll discuss Northrop's complete history and its stealth aircraft. Northrop's proposal was quite similar to Lockheed's. It was an aircraft mainly formed by flat plates. In addition, it also had the air intakes and engine exits on the top of the aircraft. The main differences were also clear. Northrop opted for a single engine placed in the center on the top, unlike the two engines on the sides of Lockheed. Northrop's proposal also had some curve, along with a crucial difference not noticeable at first glance. Lockheed's design would be controlled by fly-by-wire. They would make an unstable plane something that could be flown thanks to computer aids. However, Northrop's design would not use fly-by-wire, so they had to add curved parts to it, precisely to make it stable on its 3 axes. Both aircraft would be placed on a pedestal, about 10 meters off the ground, for the final test. It was important to place it so high that the noise generated by the ground could be avoided. The designs would be tested by rotating them so they could be observed from all angles, but they encountered a problem. The pedestal itself generated a huge radar signal that covered the radar signal of the plane, so Lockheed designed a stealth pedestal for Defense Advanced Research Projects Agency to prevent this from happening. Yes, this happened. Something else that happened was that in one of Lockheed's tests, suddenly the radar signal increased by 50%. Everyone in the room was worried, but it was a false alarm. It turns out that a family of birds were around the model. As the aircraft would be tested from different angles, a graph could be produced displaying the radar signal based on the observation angle. The x-axis would range from 0 to 360 degrees, where 0 and 360 indicate the plane is facing forward, 180 means it's facing backwards, and other angles correspond accordingly. For the evaluation, Defense Advanced Research Projects Agency considered it more important to hide the radar signal of the aircraft from the front and back than compared to the side. Since if a radar tried to detect the plane from the side as it would be moving, it could not detect it. Even if the radar signal was larger, the plane would have passed by and been lost on the horizon. However, from the front and back, the aircraft would be in the radar's crosshairs for several seconds, which is why it was more important. But would Defense Advanced Research Projects Agency give the same importance to the front signal as to the back one? And Northrop thought this would not be the case, as an aircraft that was facing away would imply that it is moving away from the radar. As a result, they considered it less significant. In addition to this, the leading edge of Northrop's aircraft was made slightly rounded so that the air would not detach abruptly as happens with flat surfaces. Lockheed, unlike others, didn't worry about this when introducing fly-by-wire in its aircraft, as a computer would control the plane. So, they were able to design a straight leading edge, greatly minimizing the radar signal from the front. All these factors favored Lockheed, and in 1976, after several weeks of testing, the winner Lockheed was made public. The next step would be building 2 flying prototypes, but that's what we'll discuss. In the second video of this series, we will talk about how these two prototypes ended up being the legendary F-117. But years later, from the F-117, Northrop won the contract for an incredible aircraft that very few know, the Whale. After this, Northrop won the contract for another incredible plane, the B-2 bomber, which we will talk about in the fourth video. Later, the competition between the IF-22 and IF-23 to develop the future air superiority aircraft emerged. And later the competition would come out that would pit the X-35 against the X-32 to be the multi-purpose fighter of the future. So get ready, because in the coming months we are going to cover one by one all the stealth planes of the United States and the secrets that each one of them holds. Thank you all, see you in the next video.